transformed indexes. What we're going to look at is that some transformations that may cause problems with indexes. And we're going to go look at a group more of them coming up also. So we have the customers table that we know for sure has the customer ID index on it because it's a primary key, but we pretty well got rid of most and we want an index on it. So in their script files, they go in and create these, but I choose not to run their script files. So I just wanted to show you there were some little utility scripts they put in here that are kind of useful if you want to work with some of these on your practice environment. And one of them is creating indexes. So what I did is pulled up SQL Developer, created a separate connection for SQLT account so we can connect to it. And one of the nice things we saw earlier on when we were demoing SQL Developer, that you can go in and have a look at the indexes on a particular table. So I picked the counties table and I went in and had a look at the indexes. And right now we only have one index on it, which is the primary key. I wanted another one. So I went back to the SQL Plus, and if I do this, it's saying host out a operating system shell script and do an ls star SQL. Look at all the SQL statements, and we've got a group of them. This one creates an index, a regular index. This one happens to create a bitmap index, a little different styled index. This deletes all indexes. This deletes bitmap indexes. And again, this deletes a more limited form of the indexes. So there are a bunch of interesting little utility scripts that we can use with these. So what I did is that there was no customer, and this example, when we actually have a look at it, wants us to check the customer credit unit and use the customer credit limit, an index on the customer credit limit. So I need to add that index. So I can do that by just calling @CI, execute my little SQL script. It will prompt me for the table name, and it will prompt me for the column on the table that I want to create the index. And then we shorten the table name to cust. That's why they use the name, because they use the script file to create it for their demo. And then we put the name of the column with a short frame for customer, and the fact that it's an index used IDX as a keyword. You don't have to follow our conventions, but if you pick a nice naming convention, it means you'll have to look at the user underscore tables or all underscore indexes less often. You can glean a little more just from the table name and that. Now, once I create it, I can go to SQL Plus and just refresh to actually confirm that we have it out there. So I should have a nice new index, and sure enough, it doesn't show up. Okay, whoops, it was the customers table. I lied to you. Go to the customers table, look at the indexes on it. We had a bunch of them, but we didn't have the customer credit limit, or it would have errored out. And it wouldn't have used this. One of the reasons why it might not be able to use an index is the index doesn't exist. So I created an index on it so for it to use. Sorry, grabbed the wrong one. Okay, now we're going to look at these two queries. Okay, if I do a query without the multiplication by 110, okay, we should be able to use the index. So let's try that. We'll just do this, just to do a little demo. It may give us slightly different results, but it should be able to use the index. I'm hoping anyways. If not, we'll have to explore why else it can't use the index. So I'm only going to cut in part of the statement. Okay, and I'm going to add the last little piece to it where it equals 1100. Hope my pasting works okay. Okay, execute it. Okay, so now it decided to use the customer credit limit index and the customers table and do the join on the two of them. So it logically realized, based on the data I wanted, I just want the customer's credit limit customer ID and some information about the credit. And it decided, instead of using one index and accessing the table, which we're kind of hoping it would do, it decided to use the two indexes to do it. So you got to take a look and see how it's actually doing it. Okay, and it decided that was the lower cost execution plan. Now, if we hide some of the data by multiplying it by a value, does it prevent it from using the index? So we want to do this one the way they wrote it, and see if it makes a difference in the execution plan. Okay, this time, because I hid one of the indexes, one index doesn't give it enough information because it could get the customer ID, but it can't get anything from the credit limit. So it has to use the full table scan to get every row and then check which ones we should include in the out instead of using the index. And it was back to looking at some of our earlier full table scans on the customer table in terms of the cost, 422 units. Where if we could let it use the index, it wasn't as cheap as using one, but it was cheaper than using the full table scan. Okay, this is doing the division on this side. Will it allow it to use that index? This side hid the index on it because we're doing a multiplication. Let's see if this one will work. And once again, proof is trying it. Okay. This time it did a fast full scan of the customer's primary key, did an index range scan of the customers, and joined them together, so it was able to go back to using the two indexes. Because by putting them on the right-hand side, it's not impacting the column with the index. Okay, we just transformed. It's a slightly different query, but you could have transformed the other one by just dividing it by 1.1, the credit, this side on the 1100. It would have came out to be the same thing mathematically. But if we put a multiplication or a division on a column with an index, it will hide the use of the index, which is problematic. Okay, so let's go and look at the next column. I should scroll down, it'll be a little faster. This is looking at some additional mismatches. And they have a group of them in here. One of them is with the postal code. Okay, we described the table. The postal code has a not null constraint on it. It's a varchar of 2. We wanted to look for one column, but this is being entered as numeric data. Because it's numeric data and the index is on a varchar 2, they're two different data types, it had to convert one of them, and it converted it the wrong way. It converted the postal code, so we couldn't use the index on it. But just another way of hiding the indexes. And for this, we actually have a group of examples that they actually have using these little pre-created outputs. So we've had a look at the first one. Okay, now we're going to look at demo 4. 0404 is demo number 4 in chapter 4. And we have a group of 5 input files to look at some different cases and that. And then we have the corresponding output for them over here to have a look at. So we'll use these. And this guy just tend to move around doing it different ways. So we'll open the first one. These are all around hiding indexes. So there are different ones. They're not the exact one that they show on the screen. You could actually do this one, that one, okay? And there is a slight mistake in this. For some reason, this actually has quotes around it and it doesn't show up. So I deleted what was their quote character and put a real quote in so you could actually see it. Sorry about that. The operating system had, what they had in their file didn't show up on this operating system. We're always changing things. So we have the customer ID, which we know is numeric data. Okay, we can actually do a describe on that if we're not sure. Okay, and we wanted to try it with a numeric value and with a character string and see how it works. Okay, when they tried it, so I'll just use their examples. Once again, you could try it on this system. The tables are there. You may have to play around with the indexes occasionally. When we did this, okay, it was numeric data. It was able to use an index unique scan, look up a unique value on a unique index because PK says it has to be a unique index. That's how we ensure uniqueness for our primary key. And then we looked up the data, so it will allow able to use the index scan. And it was a relatively cheap. We flushed it, so we forced it to use 3, okay, when they did it. And this was the one where we converted it. This time it actually converted the right way. When we did it with the real numeric value, it got the same execution plan. So sometimes it converts the right way, sometimes it don't. Here's my opinion on converts. Don't do them unless you absolutely have to, because even though for one statement it only may add a couple of milliseconds to the statement, if you execute this statement thousands of times a day, that 1 millisecond in execute can add up to be a lot of time over time. So it's less efficient than not having to convert it. Give it the data the correct way if you possibly can. So that says how you write the SQL is important to how we execute it, okay? And also, if you have to convert it, you force an explicit conversion. Don't do the built-in implicit conversion. Make sure that it converts it so you can do the index. This one was able to use the index. We're going to see some that aren't able to use the index. So let's look at some more. Second example, okay? We dropped the postal code index on the table, created a new index on the table, okay, and run 3 queries, okay. And the queries are, we're going to give it as numeric values, we're going to give it as character data, and then we're going to to-char it. Now, what type of data is it? In the postal code column, it's a varchar, which is character data. So this is the minimum cost version of this query in reality in terms of being able to use a good execution plan if we had an index on it. If we don't have an index, okay, on customer postal code, and the reason why we dropped this one, we created the one earlier on with the 2 columns, our new little views, now we got rid of it, okay. And we went back to the original index on these. So this is a lower cost. This will force it to convert it. And one execution, you probably won't notice a difference if it converted it the right way. Even if it converts it the right way, it costs you time to do it. And this does it implicitly. This does it explicitly. If you just can't get it as numeric data, then convert it, but control the conversion yourself to make sure it will do the right conversion. So the idea is just to test these out, okay, to try different flavors of them on the customer table. So they have the output for that, so it just saves us a little time having a look at it. Display this one. When they did it the first way as numeric data, it converted the wrong way. We couldn't use the index. It gave us an expensive execution plan. We had to look at 1,471 blocks, the full table. When we gave it as numeric data, it was able to use a range scan. If we give it only one value on a non-unique index, we treat it as a range scan. Because it can return one row, it can return multiple rows, so they do it as a range scan. And this was cheaper cost, okay? We only had to touch 193 blocks. We got to walk the index and then pull the data up. And we're potentially pulling up one value, but it doesn't know that. It's really pulling up one value. And that was cheaper in terms of blocks than doing the full table scan, which is the ultimate. And it turned out a payback in both CPU and elapsed time Went from 7/100th of a second down to this. And it's more efficient. We didn't have to do any conversion at all. So we didn't spend a millisecond. A millisecond or a few milliseconds spent thousands of times a day can add up to a lot of time in the application. So do it the most efficient way. Okay. The last one was with 2char in it ourselves. It did it, and it got the exact same execution plan with the same time, but this is forcing a conversion. Even though we went the right way, it costs us CPU time, even though it's not measurable on this statement. It still costs CPU. You do that enough time, it's a less efficient version of the statement. How you write it makes a difference on this execution plan. So let's look at some examples. That was so much fun. We'll look at some more examples. So this was the third set of statements we have. We'll open it up. Okay, alter system flush. We're flushing it, setting there. And now what we want to do is we're doing the back to the postal code table with this one, with it unconverted and converted. Did I grab the wrong one? I may have actually grabbed the wrong one. Okay, cancel this. Did I go to 3? I went to 3, I thought I did. Display it. Okay, now I looked, I must have clicked up here and grabbed the wrong one. I sometimes do that also. Won't be the first time I've done that, because this is more like I'm expecting. So we have a table called times. Okay, it's got a time ID that happens to be a timestamp. Okay, so we're using a lookup of a character string against the time. It's a date stamp. Okay, the way it's declared. If we want to check that, we can just do an SQL plus a describe on it and then check the time ID column. And it has a unique index on it. So by entering one date, it was able to do a unique scan on that index for a particular date. And again, it gave us a nice execution plan. We only had to touch 3 blocks in memory to return 1 row, the day name for that date. Okay, then what we do is we cast it as a date. Okay. Now, because it is a date stamp, it does the same execution plan, but now we're controlling the conversion. If you got to convert, I think it's kind of nice to convert, but this one would actually convert it properly. They did the default conversion properly in the right direction so we can use the index. But sometimes they aren't always that nice to us. Okay, so we have another example in 4. That was 3. If I remember correctly, this is 4. Let's have a look at some more select statements. Okay. This is the previous one, so I went not doing the same one again. Getting late, I'm getting tired. It's the 5th one we want to look at. Bring that one up now. Come on, Trevor, you can do it. I knew it. Okay, now what we're going to do is set the NLS date format. The rest of it is for our trace files. And we're going to do this query against it. And then we're going to do a second query using the toDate. Okay, using the NLS date format where it's being changed, and see how that impacts our query. So we're having a look at this one. Display. Okay, the first time when we casted it as a toDate, it did our unique index scan on the time date, looking good. The second time when we cast it ourselves, it did the same thing. So once again, control the cast. This is a little better cast than the previous one with the toDate option, because we're now storing them as dates in this table. So we'll go back to the documentation. This is tuning a order by clause. Okay, we are selecting from the customer table and we want to order the data. If you don't put an order by clause, it's up to the server to decide the order. If you need a particular order, in this case, they want to order the result by customer credit limit. The application needs that, we need to put an order by clause. And when we put an order by clause, it usually forces a sort. Sometimes we can use an index to avoid a sort if we have the appropriate index available. So we have a group of options here to try it. One of them is using the customer credit limit, and we have an index by that. But it's actually difficult to get it to use an index to avoid a sort, because there are a number of conditions that are required to be satisfied before we actually do it. Okay. And in the notes on the bottom of the slides, they actually have the details for it. You could actually execute this, but I'm just going to talk about the results. When they do it this way, we have an index on the customer credit limit, but the index on the customer credit limit is on a column that is a regular column with doesn't have any not null condition on it, and it's a regular index. The regular balance tree indexes do not document null conditions. So the optimizer can't guarantee that this index will return all the rows, so it can't use it to solve this query. Even though it looks at a possibility, if we had an index on customer credit in it, it might be a possible way of reducing it. Okay, a column that has a not null constraint on it automatically is the primary key, so we change the query. Let's try to use the customer ID to avoid the sort. Okay, when they did this one, it ended up doing a full table scan, and then it did a sort operation. And it was sort for the order by, so it had to physically sort it. Sorts can be expensive. If they're small, we do them in memory. They're relatively cheap. If they're big, we spill over to disk. Reading and writing to disk becomes expensive. Okay. The second idea was to change it to the customer ID, which has a not null constraint, so maybe it can use it. And guess what? It chose not to use this one. It did a full table scan. Now why? The reason why is it felt it had to get the data ordered and then had to go to the table to get all the other data. It didn't feel it was as optimal as looking at the data and sort it. Turned out that using this index with table lookups after, it just felt it just might as well do the full table scan and sort the data. If we restrict the data, maybe it will do it. So we tried to restrict the data. We added an extra predicate, where the customer city equals Paris. That will reduce the data. The only problem, it's not the data on what we're sorting it by, we're reducing it. We're sorting some other data, reducing it by other data. So using an index on this to reduce the data and this to do the sort just doesn't make sense to it. It ends up doing the full table scan. The last attempt is use the customer ID for the sort, for the order by, and limit the data by customer ID to a subset. Remember we said we had 55,200. 200 customer IDs, or approximately 200, is a fairly small subset. Then it decided doing a range scan to apply this predicate and to retrieve the data sorted by customer ID, allowed it to avoid the sort. So there were really three conditions that need to be met. The order by had to be on a column that had an index to use the index to avoid the sort. The second condition was it had to be a not null constraint on it for a balanced tree index to avoid sorts, because we have to guarantee it's documenting all the rows. Null rows are not documented in a regular balanced tree index. And the third condition is got to feel it's reducing the data to a reasonable amount to make it low enough cost in this case to justify doing it.